Okay, so today we're going to be talking about how to use this DP-Calc meter to evaluate the velocity pressure, a static pressure, and a total pressure using this machine along with pitot tubes. So Parker, if you would demonstrate for us how to turn it on. It's power button, hit the button, it'll activate. If you look close, when you show the top of it, up here, it's labeled positive and negative. We wrote on it to make it more clear, but this is printed very subtly here in the plastic. I'll draw on it with a Sharpie, make it more clear. That's a good idea. So now we're gonna show you how to hook it up to evaluate these different things. The first pressure we're gonna measure is our velocity pressure. So another good practice, add a tape or something to one of your tubes, because you're gonna have two tubes that you gotta keep track of at both ends. And so we've added tape to both ends just so that we know which one's which. So you're gonna take your labeled tube, put it on this negative inlet, and then you're gonna hook up your other tube to the positive inlet. Now we're gonna travel to the other side of the tube, and we're going to look at our pitot tube. Now, if you haven't seen one of these pitot tubes before, would you get real close and show them this here? There's two tubes here. There's a spot for air to flow in here and little holes here. So the idea here is that the actual flow of the air is going to address the pressure here, but the general pressure, which is what you call the static pressure, is just going to pull or push or whatever based on your system on these tubes that are not facing the same direction as the wind. Those come together in a tube downwind. This side piece is where your static pressure will be manifest out of, and this bottom piece is the more direct line that comes and is supposed to face into the stream of air. So we're going to take this, we're going to hook it up to our tubing. We're going to take our negative tube, which is labeled with the blue, and that is going to go on the static pressure side, and then our positive tube is going to go directly downstream to the bottom side. So that right there is your velocity pressure, which is just the pressure of the air moving. Now, if you want to transition from measuring velocity pressure to static pressure, all you do is you pull out this bottom line. And so these side holes are going to continue to measure the static pressure, and it's going to be compared against just your atmospheric pressure from the other tube. If you want to measure total pressure, however, you just swap this tube to the other side, and all of a sudden your machine is going to be comparing the direct in-stream velocity and pressure of your stream to the ambient air pressure. And so that is what you call your total pressure. Nope, excuse me, that's what you call your, that's your total pressure, where you're comparing this stream against the external pressure. If you compare this stream against just your ambient pressure, that's your static pressure. And if you have both of them working together to cancel out, and find just the difference between the two types of pressures that are collected, that is your velocity pressure. All right, okay, so now we're going to demonstrate a couple of different ways that these samples are going to look. If you can back out and show our duct here. This is the duct we're going to be working with. For the purposes, you should know that the air is flowing this way into the duct. And so that's going to shape the way that we orient our pitot tube. You point the nose of your tube into the flow of the wind, and it stays in alignment with this piece here. So keep that in mind as you go. So here we are, as we discussed before, lined up for a velocity pressure measurement. And as you watch, you're going to get results on the screen. Great. And then we're going to swap to a total pressure reading by pulling this off.
Okay, total will be switching.
Okay, my bad. All right, This is total pressure. We'll fix it in post. This is total pressure. Again, you're comparing the flow coming directly downstream to your static pressure, or to down here to the ambient pressure. So now we swap it here, and this is our static pressure, where we're comparing again against just the ambient pressure of the room. But this is the pressure that's going to be pulling on the air through those little holes in the side of the pitot tube. And so that's how it's supposed to work. Your readings are going to show up on the screen. If you want to take an average, you hit this record button. It'll take an average over a couple of seconds if your results are bouncing around, and that's the way to do it. All right, so now we're going to take measurements at these different measurement types, and we're going to turn the fan on, and we'll be showing you what you see on your screen. Okay, hit it. Okay. Hold it. So again, this is our velocity pressure.
Why is it not showing?
Oh, there it is. This is our velocity pressure.
Next.
All right.
So we got 0.24.
We got about 0.24.
Static.
Now we've got our static pressure. This is what it looks like as you're taking the static pressure. Now if you observe the results, it's a much higher value.
See, negative.
Yes, it's a much more negative value, excuse me. And then we're going to swap to this other orientation. Get our total pressure. And you notice that it's sitting at about 0.2. So the underlying mathematical principle is that if you add your vapor pressure and your static pressure, you subtract your
Velocity pressure.
subtract your velocity pressure from the static pressure, and you get your total pressure, right? And so you should be able to tell that two of these numbers add up to the last one.